Good morning, afternoon, or evening, everyone. We are Grace Thomas and Meghan Lyon here to share our progress on building a sustainable quality assurance lifecycle for web archives at the Library of Congress. We are so thankful that Brenda Reyes Ayala agreed to speak on this panel with us, since much of our work was directly influenced by hers. If you haven't had a chance yet, please pause this and go listen to her talk, A Grounded Theory of Information Quality for Web Archives, Dimensions and Applications, before diving into ours. Otherwise, let's get into it. The web archiving team, also referred to as the WAT, is the technical team for the web archiving program at the Library of Congress. We work with our contracted crawl vendor who run the crawls, supply crawl reports, and stand up a wayback infrastructure to QA recently finished crawls. After crawls have been approved, we confirm transfer via AWS and make the content available via LC servers. Although we manage the program from start to finish, we do not select any content for the archive. We rely on subject matter experts called recommending officers, or ROs, to select the content, build and manage collections, and determine when a collection is complete and finished crawling. To give you an idea of scale, this is a screenshot of a Tableau dashboard showing the current status of curatorial activity. The program currently has over 15,000 actively crawling seeds, over 75 collections crawling, and about 100 of our over 200 active users of our in-house curatorial workflow tool Digiboard have actively crawling seeds. At such a large scale, it became impossible for our team to perform visual QA on every single seed in the archive. So 2 years ago, in 2020, we began a focused revamp of our approach. We've decided on two main goals for the QA of the Library of Congress Web Archive. First, to improve the quality of the captures, since we archive on a rolling basis. We don't perform patch crawling, and instead, we try to improve any issues with the crawl before the next seed list goes out the following week, month, or quarter. And our second goal is to provide a reasonable expectation of the usability of the archive. Generally, we have a lot of quantitative data available to us about the web archive, but we don't have unlimited infrastructure to parse this data. And 2 years ago, we didn't have qualitative measures to give us a framework for thinking about how the data might be parsed and used. Once we read Brenda's grounded theory work, we saw a practical path forward for tackling our enormous QA scale with a theoretical framework. Her grounded theory includes archivability, relevance, and correspondence as 3 dimensions used to assess quality of the archive. The definitions of each are here, but we will dive in with more detail throughout our talk.
Here is an illustration of our life cycle of QA. A seed list is sent to our vendor and they crawl the content. The WAT begins QA before a crawl is complete with our review of the pre-crawl analysis reports, which are reports our vendor runs to prepare for the crawls. The main benefit of those reports is that they provide us with seed issues, 400s, 500s, and -2 response codes. Once a crawl is complete and the reports are available, the WAT can begin their parallel and post-crawl QA. Parallel QA is so called because our vendor does QA in parallel with us. During post-crawl QA, the WAT reviews the vendor QA. All changes to seed URLs and scopes are made in Digiboard. New seed lists are sent out on a schedule to our vendor, which contain these updates, and the process starts over again. We'll now address each grounded theory dimension and how we apply this framework in our program during the QA lifecycle. We'll focus mainly on relevance and correspondence, but we'll start with archivability. The archivability of a website, according to Brenda's grounded theory, is the degree to which the intrinsic properties of a website make it easier or more difficult to archive. On the web archiving team, we work with our vendor continuously to improve the captures and to determine which web development technologies make crawling difficult. Our vendor makes an estimation about archivability of sites in so much as they make the decision to crawl with either Heritrix or a browser-based crawler. Before a crawl commences, they use a technology such as WAPalyzer to scan a website for frameworks, programming languages, web servers, etc. Normally, dynamic websites with a lot of JavaScript wind up in the browser-based crawler category, but we still need to switch back and forth frequently to figure out which technology works best, if at all. The web archiving team tries to manage the expectations for ROs by providing a table of guidelines, which we call Web Archiving Known Challenges. Here's a brief preview of the Web Archiving Known Challenges page. Content on this page is subject to change as the capture and replay of various platforms and technologies are constantly in flux. The next measure from Brenda's grounded theory is relevance, the pertinence of the contents of an archived website to the original website. Regarding topic relevance, at the library, we only collect what is part of the nominated seed and scopes approved by the recommending officers to be crawled and included in their collections. This is part of the curatorial workflow for web archiving. Sometimes our team recommends scope changes based on the composition of a site, recommendations from our crawl vendor, or any issues discovered in previous crawls. Size relevance is part of our team's technical wheelhouse, but it is a bit nuanced. Since it is difficult to determine the size of any given website without essentially crawling it, it is also difficult to determine whether the size of the archived version matches the live site. However, since we perform crawls at regular intervals, we can compare the size of archived versions over time, as well as identify websites that appear unreasonably small or unreasonably large, given the number and types of resources it takes to make up a website. As such, we devised a method for getting a sense of how much the crawler has crawled a given seed. Using reports generated by our vendor based on the crawl logs, we get a number of hops per seed, the depth, and the number of bytes collected per seed, the bytes, and the seed report.txt, a standard report from Heritrix with the response codes and status of each seed. We then combine this data with Digiboard curatorial data, such as the time the seed was set to crawl, the Digiboard record and entity ID, or the Digiboard collection, to get a spreadsheet, which you see in the example in this slide. We then sort and filter the spreadsheet to target the following seeds for visual QA. 1, seeds with low bytes, as indicated by the amount of bytes crawled before work compression and deduplication. 2, seeds with low depth, the number of hops beat the crawler crawled for any given seed. And 3, the set to crawl date, if we want to focus on older or newer seeds, depending. Digiboard does not contain technical data from the crawls, like bytes, depth, or response code. So this spreadsheet makes it easy to sort by a collection if an RO has a specific QA need, or if the WAT wants to do collection-based QA. And it's possible now to find all the response codes for a certain domain in a given crawl. This process doesn't allow us to compare exactly the size of the live site compared to the size of the archive site, but it does allow us to view relative size of each archive seed. For example, we know if a seed's capture bytes is 25 kilobytes, we didn't get the full site. On the other hand, if it's several hundred gigabytes, we might be spending too many resources crawling that site, or a site is sprawling and needs to be scoped down. We think of the bytes and depth as data points for investigation rather than a ground truth of the live to archive comparison. And we're exploring the use of Heritrix posts and source reports to further investigate. The WAT and our crawl vendor collate QA findings in another shared spreadsheet. The process I've just described occurs during the parallel and post-crawl QA portion of our life cycle, and it is largely an iterative process. For the third section, we are going to focus on a new capture assessment workflow we're developing for the category of correspondence. This is the part of our life cycle most influenced by Brenda's grounded theory.
In the grounded theory, correspondence is the degree of similarity or resemblance between the original website and the archived website. Brenda defines 3 measures of correspondence: visual correspondence, interactional correspondence, and completeness. For our web archiving program, all 3 correspondence categories rely on the RO's knowledge of the live site for comparison. But in order for the ROs to give us information we can use, we needed to translate the categories into a rubric to be measured. For each category, we institute a numeric range from 1 being the worst to 5 being perfect, and the RO can use the rubric to ascribe a numeric value for that category for a single capture of a seed. If the rating of any category is any less than 5, we provide a checklist of common issues for the RO to select and communicate the issue they're seeing with that capture, including a free text other box if the issue isn't in the list. Some of the common issues in the checklist include missing images, missing documents, missing style, paywall or login impedes use, elements disappear, and issues with interactive content. This is all presented to the RO within a Confluence form. When the form is submitted, WAT gets an email with the results, and we can act on identified issues. We've tested the form with several ROs and received everything from "this form is easy to use" to "this will take a lot more time." Even though it will take longer, we feel that this process will result in a better understanding of the quality of the archive, and believe that ROs will find a groove in doing this work. WAT will be able to address issues with the crawl technology or impose additional scopes much quicker when we have more eyes on the archive and more folks identifying issues or identifying good captures. Our future plans include 1, training 100 Digiboard users to use the form. 2, exporting the form response data from Confluence into a CSV, and then converting that CSV to JIRA tickets with varying priorities depending on issues identified. From there, the WAT can prioritize review of the submissions, do any necessary investigation into issues, and consolidate this task in the team's Scrum workflow. Eventually, we will perform data analysis on the measurements of quality of the archive over time. This is why we have 5s on our rubric. We want an overview of good and bad captures, not just issues. The entire QA ecosystem we've built and are building will allow us to keep track of the quality of the archive at a high level with the data analysis of the quality measures, while also identifying and addressing sites with individual needs at scale as crawls finish. We want to thank Brenda again for making her grounded theory available to the community, and to all of you for watching. We look forward to your questions about any aspect of our process during the Q&A session, or don't hesitate to contact us via email. Thank you so much.